Hey guys, check this out. It's pretty neat. It's an underwater laser tag system, which, you guessed it, is a laser tag system that works underwater. I hope you're as excited as I am to build this thing, because we're about to get started. Before we get started, we're going to drop some schematics. We're going to start with the laser. This laser, this 5 megawatt laser, will be connected to two wires, one positive, one negative. The positive terminal will go to the positive side of a battery. The negative terminal will actually connect to a button, where one side of the button, one terminal, will be connected to one side of the battery, and the other side of the wire will be connected to the other side of the terminal, allowing it to be able to be toggled on and off from outside of the pool from a distance away from the laser once the laser is attached to the SeaPerch. The second part of this project will be our lens and receiving contraption, which will be a 3.5-inch lens connected and taped and waterproofed to a 2-liter bottle connected to a photogate on the other side that will be able to sense the laser once the laser is able to shoot. And this lens allows the laser to be able to hit anywhere on this lens and still get reflected back into the sensor. So now that we know a little bit more how this works, let's go and build it. For the laser emitting component of this device, I used two 5 megawatt 532 nanometer green lasers, and alligator clips were first attached to the power terminal, or the spring inside the laser, and to the metal outside case to allow for the complete circuit when the power source was attached to the laser. Then a thin piece of plastic was held in place over the end of the laser with a rubber band. I just cut out a piece of the 2-liter bottle and cut it up so that it could be fit over the end of the laser with the rubber band. Liquid electrical tape was then applied until there were no seams on either side of the laser, making it waterproof. I had to apply a few coats before there were no holes, and it looked waterproof to me. The next thing I did was solder 30 feet of wire to each end of the alligator clips, and I just stuck the bare wire inside the alligator clip and soldered it on to make sure it wouldn't come loose once I waterproofed it. I then took electrical tape, wrapped it around, then I took liquid electrical tape and applied it until I was sure that it was waterproof. In order for the laser to be able to be toggled outside of the water once the laser was attached to the SeaPerch, I needed to make a switch that could be toggled on and off outside of the water. I did this by taking a normally open push-button switch and soldering it onto one of the ends of the batteries. Careful attention was paid during this process as well to make sure that I knew which wire was positive and which wire was negative so that I could connect them to the correct sides of the battery once I was ready. After the button was soldered to the battery, I took one wire and taped it to the other side of the battery. The other wire I took and soldered to the other terminal of the push button, and I tested it beforehand to make sure that I had the right wires where they needed to go. The button, battery, and wires were then covered in electrical tape to preserve the integrity of the circuit. At this point, the laser was ready to be attached to the SeaPerch via zip ties and used underwater. So now that the laser's done, we can see that it's working above water. Let's go see if it works underwater. Look at that, the laser works underwater. You can even see the beam, it's pretty cool. Now let's move on to the sensor and see how that's built. So before we were able to build the enclosure for the lens and the sensor, we had to find the focal length of this lens. So to do this today, we're going to use a candle, this lens, and this piece of paper. And we're going to show you how to do that right now. So first we're going to light the candle. And then turn the lights off so we can see a little better. So with the lens, you can line this up with the candle, and the box is exactly 3 feet away from the candle, so that when we move the lens back and forth, you can actually see the candle focusing in on the piece of paper. Can you get close to the paper now? You can see it actually focusing about right there. So we're going to mark that spot on the table, piece of paper, and then measure it. So we're done with the candle now. You turn the lights back on. So what I'm doing here is measuring the distance from the candle to the lens and then from the lens to the camera to find our focal length. We find that the distance from the candle to the lens is 12 inches and the distance from the lens to the paper is 24 inches. Which means the numbers we're going to be able to use in our equation is 12 inches and 24 inches We plug that into the focal length equation of 1 over distance plus 1 over distance equals 1 over the focal length. We get that the focal length is 8 inches using those numbers. Now we can continue on. So after the focal length was found for the lens, a conical case was able to be fabricated from a plastic 2-liter bottle to house the lens and photogate. This was done by cutting the bottom off of the 2-liter bottle and then placing the lens inside. I then marked the edge of the bottle where the lens was touching and then took the lens out. Then I was able to cut around the marked line and place the lens back in, making sure that the plastic was as close to the edge as I could get it without the lens falling out. I then sealed the lens to the edge of the plastic with silicone. After that had dried, I applied more liquid electrical tape to the edge to make sure it was really waterproof. Then I took the waterproof reflective tape and lined the inside of the bottle with it in hopes that the laser would be able to reflect better and hit the sensor more often. In order for this to really work, the bottle needed to be the exact length of the focal length of the lens, so I had to cut another piece of plastic and make the bottle a little bit longer. I did this by cutting the plastic and taping it onto the bottle. Once all this was completed and there was tape lining the inside of the bottle and it was at least 8 inches long, I made cuts running lengthwise down the side of the bottle so that the strips of plastic that were made were still attached but could bend together to make a cone. I made sure that this cone was still at least 8 inches away from the lens. I then took tape and taped around the edge of the plastic bottle so that it stayed in this conical shape. I did my best to center the end of the cone with the center of the lens so that when the photogate was attached, the sensor would line up right with the middle of the lens. Once the cone was taped in place, I measured again, and this time I cut the cone to be exactly 8 inches away from the lens. Then it was time to attach the photogate. The end of the cone was placed on top of the photogate directly over the sensor. It was really important to make sure the sensor was directly in the middle of the cone hole, so that the light coming through the lens would always hit the sensor. The photogate was then taped to the cone using the waterproof electrical tape and covered in a Ziploc bag to help keep it even more waterproof. The Ziploc bag was then rubber banded to hold it on, and more tape was applied. After tape covered the entire enclosure, liquid electrical tape was applied to the seams in the holes to make sure that no water would be able to get in. A few coats were applied and the enclosure was visually inspected to make sure that I got all the seams in the holes before I was comfortable moving on to the testing phase. Now that we have our enclosure built and waterproof, let's go see if it works. Ooh, it glows, and the sensor is set off. That means it works. Now let's see how the data is recorded. So this is the LabQuest connected to a photogate. Once the photogate is connected, the LabQuest will bring up a screen saying whether or not the laser is blocked or unblocked. As you can see, as the laser is shined at the photogate, the LabQuest records when the gate is unblocked, every time it senses the laser. I know you're excited to build this, so here are the needed supplies and list of tools. Have fun building this SeaPerch laser tag system. Good luck!